Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. This episode is a conversation with Andrew Rodgers, co-founder of ACE IoT. This is a follow-up from our first episode with Andrew on defining open. This time we dove into the independent data layer of the stack and specifically how the open source software Volttron plays in this arena. All right, Andrew Rodgers, welcome back to the show. Can you introduce yourself again for us, please?
I'm Andrew Rodgers. I'm the co-founder of a small company called ACE IoT Solutions. We deliver a couple of products and project support around an open source platform called Volttron. And we have a data lake infrastructure as a service platform that we offer for facilities and operations technology data.
Absolutely. And you were on episode 20, I believe. So it's been 6 months or so. And we're going to build on that conversation in this episode, but probably not replay a bunch of it. So if you haven't listened to that episode, you don't necessarily have to go back to it, but you might want to. We'll kind of touch on a lot of the same topics. And that conversation, we talked about interoperability and openness at each layer of the smart building stack. And I learned a ton that I've been using ever since we had that conversation. So what have you been up to for the last 6 months?
Well, we've really just been focused on building out our platform. We've been kind of drawn by some of our partners into a few different verticals that are a little unfamiliar to us. So it's been a lot of fun exploring that. We've got sort of this converged, obviously our sweet spot is in buildings and around buildings, but we're getting drawn into more municipal infrastructure, water supply, that sort of stuff. So we've been doing some of that. And we've also been working more with utilities on sort of broader, scaled out demand response and distributed energy resources, which is sort of in the pedigree of Volttron, what it was developed for in the first place, but the market's just now kind of catching up to that.
Absolutely. Yeah. And that's what the focus of today is on to kind of digging into Volttron and what you guys use it for. But first, on the water side, I want to ask you about the hack in Florida. For people that don't know anything about the world outside of buildings, that would be like an industrial use case or an industrial case study, I guess is a better term. So what happened there? Can you kind of fill us in?
I mean, I watched that and it's so interesting. I have so many thoughts here. There's a tendency when these things happen to sort of talk about them without a lot of knowledge or real information about the event. There were a few keywords that kept showing up in a lot of news reports, like there was no firewall. It's like, well, what does that mean? Do you mean there was an internet connection plugged directly into a computer? Probably not. There's probably a router. There was probably a firewall. Just obviously traffic wasn't blocked. And then secondly, they were running TeamViewer. You know why they were probably running TeamViewer? They were probably running TeamViewer because some draconian IT policy was preventing them from deploying a technology that allowed them to securely manage remote access or, getting the information they needed, data egress, whatever. And I always go back to Jurassic Park on this. Okay. Life finds a way, right? The more draconian your policy is and the less you interact with the folks who are, solving the day-to-day problems and need solutions, the more likely it is they're going to go around whatever that policy is, and you're going to end up in a situation like this. Should they go around that? Absolutely not, right? Nobody's arguing that it should have happened or that TeamViewer should have been running unsecured or without the password, being rotated or whatever. But, without better solutions in that space, and if you compare that to what we see every day in buildings, ports forwarded into JACEs that haven't had their passwords changed in 10 years, passwords the same for every building that vendor ever touched. It wasn't the worst thing that could have happened. And then if you really pay attention to what some of the real people who really focus on things like critical infrastructure security, like the other controls that should have been in place were missing as well, right? Like you don't put in a chemical pump that can pump enough chemical to poison somebody into the water supply, right? Like there are those kinds of controls that should be in the engineering of a plant like that we're missing as well, which I think is the more interesting part. Like, you know, you can maybe disable whatever security, like there's always some sort of security hole, but like if the pump can't pump more than a certain amount of liquid, like that's a hard limitation that you can, you know, use to deliver this like assuredness that maybe our critical infrastructure deserves. And finally, the last point is that just obviously as a society, we critically underfund our critical infrastructure. And like, this is just a symptom of that. There will probably be more instances of that happening. We're very excited to be able to work in that space because we are able to deliver secure data egress for these platforms and enable people to do their jobs better, respond to incidents, 24/7 without needing to open up a team viewer to the SCADA system or, drive into the plant. So, yeah.
What are some of the use cases that you're deploying as someone that kind of, you didn't originally come from the buildings world, but you guys are primarily doing buildings related work for the most part. So what are some of the use cases that you're deploying on the industrial side of things?
I mean, it very much looks the same. It's connecting using, some of the legacy protocols that are kind of painful to navigate from a technology perspective, and collecting that data, getting it into a normalized form, getting it into a platform with easy access for whatever, downstream application. So it's more or less the same thing, simple, alarming. I think we kind of got into this a little bit last time about what is fault detection. So like, we can do multivariate alarms, but I'm always hesitant to talk about doing fault detection because I think that's like the people that are really doing that have done a really good job. And the problem is a lot of people say they're doing it and aren't. Yeah. I don't want to be one of those people who says that's what we're doing when we're not. But we do, support things like, when the chlorine level's high, there's an alarm and somebody gets a text and they can go look at the graphs and see what happened and which pumps are on and that sort of stuff. So it's the same kind of, all these processes look the same from a conceptual perspective. You've got some product that you're making, water, air, conditioned air, whatever. You've got some critical values that contribute to the successful generation of that product. When they go out of range, you want to know about it, and you want to be able to see when it happened and what other contributing factors, were causes are playing in that event.
Totally. That's a good segue into the conversation I want to have today around Volttron. So before we get into Volttron specifically, I include Volttron in the greater umbrella of what I call independent data layer, but there are other terms that people use, data lakes. I'm sure you have a bunch of other ones as well. But let's just kind of define what is the independent data layer and what sort of makes it unique.
Sure. So the independent data layer is really about, if you referencing our last talk, I think at the end you forced me to come up with some one word answer to this question of what is open, and I said choice. And I think that that's ultimately the problem that an independent data layer solves for, is giving the owner, the operator, the facility manager choice on what kinds of solutions they want to bring to bear for different kinds of problems within the system. So it's easy to imagine there's a lot of energy management information systems, right? So those can be independent data layers from, doesn't matter who your meter manufacturer is, you're bringing all that into one EMIS and you've got this independent layer, and maybe you have access to that data in some standardized format that you can use in other tools. Maybe not, but it's not a proper, EMIS is not necessarily an independent data layer, but it can be.
Yeah.
But ideally, that independent data layer is bringing in data from all kinds of systems. You've got metering data, you've got the facilities operations data, the actual BAS equipment data, central plant data, battery storage system data, solar panel, your PV system data, all of that into one platform where you can start bringing things together. And now we're talking about things like access control, occupancy. We're talking with one customer who brings in all of their gym equipment usage into this independent data layer where they can manage and make decisions based on, how much equipment's in use at the gym can drive the ventilation level for the gym. So
Okay.
once you have those kinds of integrations, and then I think there's kind of two very separate classes of independent data layers. There's a lot in the one-way data collection side. There are fewer in sort of the two-way, where
Right.
you are offering not just a normalized interface for the data itself, but then a normalized interface for writing back process variables, process set points to those systems. And generally, when you do have that two-way control, I think this is kind of maybe muddying the waters between independent data layer and advanced supervisory control. But, sort of with the same as with advanced supervisory control, you kind of keep your low-level loops and sort of real-time critical stuff out of that system, and you're just kind of putting in the kind of overarching set points, variables that are less frequently changing, or just sort of inputs into a real-time process versus running any of those real-time processes directly in that layer.
Right, right. And the reason I call it independent is because it's different than what we have today, which is a full stack point solution, which is kind of like the state of the art in smart buildings right now. So it's basically saying we're going to chop that up. We're going to say, okay, right now we have like an integration layer, we have a historian database, we have some sort of data model in that historian database, and then on top of that we have applications that provide some sort of, user interface for the user. Right. And so what we're saying with independent data layers, for the most part, we're chopping that in half. So you're performing the integration, like you said, one or two way, and then you're storing the data all in one place, and then a common data model as well. So what about that data model piece? What's sort of the state of the art right now when it comes to that? Both of us start laughing when we say state of the art.
I think this is, I laugh so I don't cry. I think this is the most depressing thing about our industry right now, is that this conversation, it just keeps continuing, and there doesn't seem to be any actual resolution. And to the point that people are like, someone someone responded to a LinkedIn article I posted recently against standardization, as that being an evil force. So all that to say, it's very complicated is where things are at right now.
Yeah.
In my opinion, we need to standardize. We need everybody in the industry to put their grown up pants on and agree and find some common ground. We know from experiences in the IT world, in technology world, that once you have a common infrastructure, a common standardization for infrastructure, once you have HTTP, once you have the World Wide Web, there's all of this value that's unleashed. And, where we're at right now is CompuServe and AOL. We've got literally those walled garden approaches.
Can you explain that for those of us that aren't old enough for that?
Oh, wow. Yeah. So before the internet, as the internet was developing, the internet as the internet, capital I internet, proper noun, was this thing developed in research and, defense organizations. And that's where all the peer-to-peer networking that really makes up, and I say peer-to-peer networking, I mean routed traffic and IP, all that stuff was developed. But, before all of that, there were these online service providers. It wasn't really the internet. They were not standardized. They weren't using any of these protocols that were standardized. They were their own walled garden systems, much like the Facebooks of their time. If you weren't on Facebook, then you couldn't talk to Aunt Glenda or whoever, so you were on CompuServe, you were on AOL, you couldn't talk to each other, tough crap. So that obviously has changed, and it happened once we sort of opened up and adopted open standards in that infrastructure. Otherwise we would all still be and I mean, the cycle continues, right? This is not something that's solved by any means. I mean, this is like the iPhone, Android. I mean, this exists everywhere, but it's just so bad in this industry, and everyone recognizes it's a bad thing, but then people don't seem to be willing to do the work to address it, which is why I say it's depressing. But
I agree. Well,
I think
I feel like the promise of the independent data layer is that it says we're going to do, one data model, but then like the fine text in the bottom basically says that like, well, it's not going to be anybody else's data model because that's impossible. We don't have one. And so like the subtext is that you're going to be then forcing the data model onto all the applications that are going to be writing on top of it, right?
I mean, so when you look at the private commercial solutions in this space, they do tend to be very opinionated about the data model. I think that's one of the things that is attractive about Volttron and how we've built our platform. You know, our platform, and they'll be a little tricky today separating some of the value we've added on top of Volttron in our platform versus what's built into Volttron itself. I apologize. I will try to be clear about that. Voltron in itself is not opinionated at all. It treats everything sort of natively as it finds it in the system that's being integrated. And for BACnet, for instance, that just means you get BACnet device IDs and point addresses and registers, right?
Mm-hmm.
Um,
Can you back up and let's do dive into Voltron now? We talked a little bit about it on the last episode, but assuming that people didn't hear that, what is Voltron?
Sorry, yeah.
No worries.
Um, so Voltron is a open source technology project. It was funded by DOE, led by Pacific Northwest National Laboratory, really around the idea that DOE was doing all these really interesting, what they now call grid interactive efficient building projects, GEBs. At the time, I don't think that term was really a term of art.
I think it was
But
grid integrated buildings back then, which I
distributed
like
energy
better.
resources, etc. And they had this problem, which I've done a decent amount of work in research computation, not in the national labs like James has, but more in the academic side. There's a lot of just wasted effort in like recreating simple boilerplate stuff that you need. Like, for instance, if you're doing research on the absolutely best optimization strategy, like every grant would have funding in it where you do the integration again. So like, everybody's like connecting the test, air handler to MATLAB in every single proposal. Like it's the same work being done by different grad students, and like you don't even get the same grad student who's already done it once before. It's a new grad student who has to learn the whole thing again. So DOE was really trying to say, like, let's build some infrastructure that enables this research to work faster and cheaper.
Okay.
So that's really where Voltron came from, was enabling rapid testing, safe operation. So like when you use Voltron as a two-way platform, it has all the semantics built into it for managing what priority things get written to in the BACnet controller, those sorts of things. It has automatic rollback. So if your application falls over, Voltron will detect that and set rollback to whatever the previous set point was before your application overrode it. So it's got a lot of really cool features around that in the building space. And then it was more broadly, not just the building systems, but designed to sort of bridge that gap between building automation systems, BACnet, Modbus, that sort of stuff that was in the building envelope, and the grid scale, utility distribution system protocols like DMP3 and OpenADR and those sorts of things. So it was really built as an infrastructure platform that allows people to build applications rapidly and cost effectively by kind of solving some of these boilerplate problems that you just solve over and over otherwise.
Yeah. And so how do you basically took it got turned into an open source project through the Eclipse Foundation, I think.
That's
And
correct.
then
Yep.
and then people like you, there's probably other firms like you guys, then build onto it and create your own product. Is that how it works?
That's right. Yeah. And so like for us, our cloud platform is very much our product. There's not a lot. I mean, Voltron is involved in the data aggregation and collection, but then once it hits our platform, like the data lake and the visualization, all that stuff is completely different technologies that we've assembled and put together into that platform. But we try very hard to keep the edge resources pretty much vanilla Voltron, just so that when one of our customers wants to deploy some sort of Voltron application that's not ours, they have that capability and that choice. Again, back to, kind of built into our ethos is giving our customers as much choice as we possibly can while maintaining. I mean, the risk here, or the cost model, how you think about this as a business problem really is, the more choice, the more risk, and you have to pay for that risk somehow. So it's always, for us, it's always walking this really, trying to find the best balance point for giving our customers as much choice as possible, while still like keeping it manageable where we can offer a good product for a good price.
Totally.
Hey guys, just another quick note from our sponsor, Nexus Labs, and then we'll get back to the show. This episode is brought to you by Nexus Foundations, our introductory course on the smart buildings industry. If you're new to the industry, this course is for you. If you're an industry vet but want to understand how technology is changing things, this course is also for you. The alumni are raving about the content, which they say pulls it all together, and they also loved getting to meet the other students on the weekly Zoom calls and in the private chat room. You can find out more about the course at courses.nexuslabs.online. All right, back to the interview.
Well, the reason I wanted to dive into this today with you is I feel like this advanced supervisory control piece is hot, right? And the independent data layer is hot, and Volttron, is a key tool for both of those things, right? And I wanted to ask you around, like, why would someone build their own piece, like proprietary black box inside the building to do that two-way integration, and why shouldn't they? I guess. And you just you said it, but why don't you say it like to everyone else? Why shouldn't we do that?
Yeah, I mean, I would say there are good reasons to do that, and there are good reasons to not do that. I would say that, like, if your business model is a traditional business model in this space of capturing a customer and like tying them down as hard as you can and giving them as little choice as possible, then write your own, right? Like, use the most obscure stuff you can, because that's how you're going to like keep them locked in. But for the rest of
Terry
us,
Herr calls it lock 'em and loot 'em.
Yeah, he does. So for the rest of us, though, like, who are trying to maybe see a better future in this space, I would say this, and I do say this to the Volttron team at PNNL. I'm, one of the most active community members outside the lab system for sure. I'm also one of the ones who's like first to question everything. But there are things in the Volttron project that I don't agree with. Like, I wouldn't have done them that way. I don't like them. I don't think it's the right way to do something. But the value of being in an ecosystem where there are other people using that technology, where we have sort of this plausible presentation to our customers that, like, yes, we're a small company, but we're using this technology that is open and, there are other providers for. So if you decide that, like, we're not delivering, you can fire us, and you're not left holding a bag of some proprietary crap that you can't do anything with. Mm-hmm. And that value, again, it's a very different perspective, right? Like, of course you want to tell your customers that if they fire you, they're going to be left, they're going to have huge amounts of cost to, recreate so, that's why I say, like, from my perspective, and I think maybe from the reality you would like to see in the world, no one should be doing it that way. But if that's your business model, that's your business model. And I mean, I'm not here to, I'm probably not going to convince you otherwise. And
if that's your business model. Yeah.
Yeah. So, but I would encourage you to investigate, maybe we should be working on delivering value in a little more, again, interoperable way. Like, our goal is we solve the data aggregation, putting the interfaces together to allow control, this advanced, the advanced supervisory control. We solve that problem really well. We don't compete with fault detection companies. Like, we love it when our customers take our platform, bring the data back to a common layer, and then hire a fault detection company to make sense of that data or deliver some, direct value. And then turn around and say, oh, well, our AFDD company, like, they do everything really well except for this one weird system that, like, we're the only ones that have because, we made dumb decisions in 1980 or whatever, right? And then because they have this independent data layer, they have the choice to say, oh, well, we're going to invest, a few months of development time with our team to build something special that does that for us. and we have that flexibility. Whereas if they had just went with, an AFDD vendor's data collection tool that kept everything in a closed ecosystem and wasn't open and accessible, they would not be able to unlock that value. So
totally,
that's where I think the independent data layer really starts to shine.
And who are the other people that are in the community, the Volttron community, besides the PNNL folks? Who is the people contributing back to it?
So there's a core user group at pretty much each national lab that obviously that is still using Volttron and working with Volttron. Companies offering Volttron as a service, there's not that many of them. I would struggle to name one who's like doing it in a way that's not competing with any of the existing players. Like there are companies that do fault detection and then they use Volttron under the hood to do that. There are companies who are doing, completely managed building optimization services using Volttron. But we are probably some of the only ones who are out there like selling it purely as the platform play.
Yeah. And how do you guys sell it when it's not your product added on top? It's an open source piece of software that you're setting up. How does that work?
I mean, the way I like to look at it is, anybody can go download Volttron off GitHub, start running it on their computer, run it, install it on a Raspberry Pi if that's what they want to do. Anybody can do that. What we bring is tools that allow us to deploy faster, collect data better, more efficiently, monitor for changes in the network, monitor the hardware platforms we deploy, and maintain the health of those hardware platforms. We're really selling a service around reliable data acquisition that Volttron plays a central role in, but it's really this suite of the monitoring, maintenance, all that stuff that we're offering on top of Volttron is really where our value comes from.
I see. Let's talk about the grid interaction piece of it a little bit. So Volttron has that. I mean, that was one of the intentions when it was created. It was to be used for a building to interact with the utility, right? What's the status of that today? And what are you seeing on real projects? Because I think where I'm at is, leaving NREL 6 months, 7, 8 months ago, however long that was, I'm kind of out of that world, but like, there's still this like opinion of mine where it's like, we're talking about a lot of hype for this and well-reasoned hype. Like we need to decarbonize the grid. In order to do that, we need to have load flexibility. Totally 100% behind that. But what we haven't talked about is like what buildings are out there doing it and why are they doing it? And does a building owner care about interacting with the grid? And so I guess what I'm asking you is like, give me an update on like load flexibility and grid interaction in 2021. Like where are we at?
Yeah. So, I mean, Volttron has been being used for pilot demonstration projects with utilities in this space since its inception. I mean, probably day one with Volttron was the actual use case for it. What we see is utilities starting to talk to us and say, hey, we've been working with, Oak Ridge National Lab, Pacific Northwest National Lab for years now on these pilots. Can we get this thing to scale? Like, is this ready now? Can we actually do this? Can we start seeing aggregate benefit that is going to justify the investment? At the same time, I think you're seeing things happen in buildings that are, in the actual owner market in buildings that are pushing, local law 97 in New York, right? Like, it doesn't directly affect grid interactivity, but because it's making people go out and touch these buildings and do data collection, do a lot deeper analysis of how energy is being used, then you start to see the movement that allows demand response or active load management to be kind of shoehorned into existing projects. Like I think there's a huge shift, but I still think in 2021. No one is going to go out and say, oh, it is worth it for us to go deploy all new infrastructure in our portfolio to achieve load flexibility. Like nobody's going to do that. But when it's, hey, we're going to install vehicle chargers because our tenants are demanding electric vehicle infrastructure. To install electric vehicle infrastructure, we've got to put 200 kW of kWh of batteries in, because that's the only way we can do it without completely upgrading our utility service, which is going to cost $1 million. That's when you start seeing, oh, well, for an extra tens of thousands of dollars, we can use this for demand flexibility. We can do our peak shaving, like we get all these other ancillary benefits. Because there's already capital moving, I think that's where we'll see the most adoption on the building side. The utilities are actually really interested in this stuff on the residential side as well. So we're working with a few utilities on residential demonstration projects where you start asking the question, okay, if people are putting, Tesla power walls out there and rooftop solar and an electric vehicle in the garage and a water heater that's connected and, a smart thermostat that's enabling control of the HVAC, like if we start aggregating 100 houses, 1,000 houses, 10,000 houses, like we can actually start making a dent in peak demand. So I think we're approaching market readiness. I wouldn't say we're like at full market readiness yet, but I think the market is in a much different place than it was 2 or 3 years ago.
And so what does the stack look like from a Volttron perspective with that aggregation? You got a local node in each of the houses or in each of the buildings, and then you have
so it
one
depends, right?
on
Like
the aggregator side?
We've done some demonstration projects where Volttron is just operating in the cloud, kind of being an integration layer between a bunch of different cloud APIs. But when you start talking, especially in rural America, where things like battery storage can make a huge difference in electricity reliability on long distribution lines, right? Like you put a few tens of kWhs of batteries out there, and a storm falls a tree across the line somewhere, and you can keep people's like critical services up. Like that can have huge impact. And I mean, Texas this winter, I think, is a great example of such a big failure at a massive scale that like the communications infrastructure failed too. So like even if you had smart thermostats, it didn't matter, because if they're going through a cloud round trip, they weren't getting out.
Right.
So there's this desire on the utility side to really explore more resilient applications, right? So like if you've got a battery attached to a house and you've got solar panels on the roof, can you island that house and shut off all the non-critical loads and keep the refrigerator and the temperature in the house above freezing for 48 hours? Like, and for that you need edge compute capacity, you need edge integrations to really deliver that in a way that's fault tolerant.
Totally. Very cool. So let's talk a little bit about Volttron sort of in context to the other ways of doing things. So we talked about the fully open model. What are the other ways that like the independent data layer is being provided today? Like one of them is that I'm curious about. You've talked to Mike Bruman about SmartCore. I'm sure. Like how does Volttron compare to SmartCore?
So Mike and I had a really great conversation. I think both of us are excited to work together. It's just finding the right application. But SmartCore is much more focused on like day-to-day operations of the building and interaction of sort of user interfaces. And Volttron has almost zero focus on that, right?
I see.
Volttron is about back-end services, enabling these complicated control algorithms that need data from a lot of different sources and need to write set points back out to a lot of different systems. And I think the other thing SmartCore does not focus on at all is that grid integration piece. So Mike and I had talked about some applications where SmartCore might be doing all of the systems dashboarding and HMI, all that stuff in a building, and then there would be a Volttron instance that it would communicate with as well in order to manage the grid to building interaction.
I see.
So I think specifically with SmartCore, I don't think Volttron has. Voltron is just a very different approach.
Yeah.
and maybe you can get to the same place both ways, but I think depending on who you are or where you're coming from, you would pick one of those tools versus the other, versus necessarily like the specific problem you're trying to solve, other than like the UI stuff. That's all SmartCore, and Volttron just really doesn't even try to address that.
Yeah, got it. What about the other alternatives, I guess, to doing sort of the open independent data layer on Voltron?
Well, I don't know that there are a lot of, I mean, there's not a lot of alternatives for a truly open independent
Mm-hmm.
data layer right now. Like we see a lot of vendors doing their own models, their own sort of proprietary solutions. And the question I'm always left with kind of, or the question I'm always asking when I review those systems is, like, where is the choice? Like what happens if I want to separate myself from this company in the future? Where does that leave me? Do I have a path where I can, take my data and re-implement another set of infrastructure that will allow me to collect the data I need? Like, does that mean I need to completely redo all of my applications? So that's where I think Voltron has sort of a unique focus. There doesn't seem to be a lot of market pressure otherwise for these companies to really be open.
Mm-hmm.
The other thing that, it seems like there's a lot of effort on the companies who are saying, like, we're delivering an API for your building, those kinds of value propositions.
Yeah, there's lots of those.
Yeah, they're controlling all of that. And, if you're just using the model they have, you don't have control or choice in, if you want to add additional features to that model that are specific to your use case. It's not clear to me how someone can deploy something that implements a somewhat proprietary model and decide you wanted to swap that with something else. It's not clear how you would go about recreating that data collection infrastructure in a way that was self-actualized.
Absolutely. Especially when you start to talk about connecting a bunch of different applications to it. So if you just have, if you picture just a point solution today, you have one application connected to a data layer, right? That's great. It could be pretty easy to swap out components there. But when you start to talk about like the true value proposition of the independent data layer, when you have, all these different applications plugged in, right? And now you're swapping out the infrastructure piece, that does sound very, very difficult. Interesting. So how about let's go back to Voltron a little bit, the advanced supervisory control today. Like, I think I'm always wanting updates from the field on this because it's still an area where I think you have about 50-50 of, like, there are a ton of startups that obviously believe that it's the future, right? I think on my vendor landscape, it's up to like 15 to 20 now of people doing this cloud application, providing advanced supervisory control. And then there's the other 50% of the people that it's like never going to happen, right? like this is absurd, right? That we would provide control from somewhere else besides the automation system or the system that was designed to control the systems. So, like, can you provide an update on the kind of where the market's at today? I think this is an important question because in order to make things like grid flexibility happen, right? Like we talk about, we need grid flexibility, but in order to make it happen, we as an industry have to kind of get on board with the advanced supervisory control. It's just a fact.
Yeah, and I mean, I guess I just have commitment issues. Because in all of these questions, like, you'll ask, well, is it this way or this way? And I'm always like, well, we just decided to support both because it turns out, like, that's where so when we talk about data modeling, like, we are not opinionated about data modeling. We built out infrastructure to support whatever models our customers bring to us. We talk about, edge control versus cloud control. We have customers who are saying, hey, we actually already have an independent data layer. We did it early. We're very advanced, but we didn't get two-way control, and like our vendor's not going to do that, or the system we built out internally is not going to do that. Can you go deploy Volttron and just give us an API for writing back like these key set points from your cloud? Like, sure,
Okay.
that's like super easy for us to do. But then if you want to like drink the Voltron Kool-Aid, maybe you say, hey, can you put Voltron in our buildings and give us a platform for us to deploy these applications that we want to develop that are doing this automatically and run at the edge? And the answer there is yes as well. Like that's why we kind of focus on doing this, sticking to as close to vanilla Voltron as we can in those edge applications, is so that we can take these packaged, what in Voltron world is an agent, which is basically an independent application that runs in the platform context with access to the data that you provide it via sort of an access control list. So if you're familiar with deploying things into cloud environments, you can choose very granularly what data a particular application has access to. And there are there are really great open source things that the labs have built that are available as Voltron agents. There's one called Intelligent Load Control that PNNL has built out that's all around sort of doing peak demand limiting with comfort in mind. So you can kind of prioritize spaces in your building and then set a target load profile that you want your building to maintain. And it will kind of shed load in a weighted way that tries to keep your priority zones happy. And then maybe we'll give up on shedding load in order to maintain a certain like threshold of comfort that you're not willing to go outside of. And so that's like a Voltron agent that you can, as again, open source, you can download it, you can install it, run it on your building and achieve, peak load reduction. Pretty straightforward. So that's like the fully drinking the Voltron Kool-Aid way to do it. It's running in the edge, it's resilient, it's kind of giving you all the value proposition that people would say that your existing BAS gives you, but it's still a supervisory system that can pull in data from a lot of different sources instead of just the BAS itself. And you get cloud or, external connectivity oversight, so you can easily connect, bring all that data back to one place while the actual decision making is happening at the edge. One of the things, and I guess this is my experience in the industrial world, but I was amazed when I started in building automation and found out that a lot of these startups you're talking about who do, say, the independent data layer, like a lot of it's like they install a VPN and then they have like a backnet client in the cloud somewhere talking to the BAS over this VPN link. And if the connectivity goes down, you don't get data. Like there's all kinds of reasons not to do that. And it just, in the industrial world, that would have never flown because you don't want to give up having your data just because your internet connection's down. You
Right.
want to proxy that somewhere locally. Voltron does all that for you. So not only can your edge device be sitting there running some optimization strategy, it's also collecting the data, buffering it locally, forwarding it to the cloud, so you still have sort of a portfolio-wide supervisory view of what's going on, but you can actually deploy those control algorithms directly to the edge device.
Absolutely. Interesting. That's good enough for me. Like that you had me at like our clients are asking for this. Like I feel like we just need more case studies around actual building owners investing in these types of controls, because I still think again, I already said it. I still think that we're not quite as an industry decided that this is a good idea at this point yet. Yeah, and I've heard several people that like several building owners, large building owners that have I just heard about recently that are investing in this approach, and we just don't have enough public case studies on it yet.
Yeah, I mean, it's one of those challenges because if you're really good at it, it's definitely a competitive advantage.
Yeah.
And, if you're a big either portfolio owner or manager, you don't necessarily want to talk and give away all this, great ways that you're improving your return on your investment.
Right.
So it's a little tricky. I still think, Joe Gaspardoni always makes this point that like CRE is the hardest place to do this. And, REITs are really hard to do this in because everything is driven by this value proposition and return on investment. But I do think from what I've seen, it's like some of the most interesting things are being done by the private private and commercial owners instead of the campuses and universities and such.
Totally.
I think it's that 300 thing that drives that, and then like the future's already here. It's just not evenly distributed. Like somewhere between those two between those two cliches is why there are a few property owners doing really cool stuff today, and we don't hear about it a lot.
Right. Right. Totally. Well, this has been fun. I think that's the end of my current round of questioning for you. Did you have anything else you wanted to kind of get off your chest this round?
I don't know. This is always good to catch up. I appreciate you having me for sure. I'm always happy to talk to anyone about Volttron. It's very exciting to me as a technology. I've talked about, I think you'll see, like, and I post things on LinkedIn a lot, and I talk about market transformation forces. I think Volttron has that potential. Not necessarily that everyone's going to adopt Volttron, but that open platform that exists that does some of these functionalities is just a pressure point. Like, it's our pressure source, I should say, to move the needle. And, that may mean that, like, Mike Bruman at SmartCore sees Volttron as like, hey, if they can do it, I can do it. It might mean that, someone has to bid against a Volttron solution, and it encourages them to change something about their product that makes it more open. Like, there's all kinds of ways, the existence of something like that can change a market. I think I posted recently something I was really amazed, like this really great industrial controller based on the Arduino platform, very low cost, really cool features. And to see how the accessibility of embedded development, of industrial control using open technologies, all of that's been moved by like some crazy professors in Italy who wanted to make embedded development easier for their students. Like, Arduino as a market force is a really interesting story, and I think it has a lot of parallels in what something like Volttron and SmartCore can do in this sector.
Amazing. Well, I'm excited to keep getting updated. I always love your LinkedIn posts, so please keep it up. And we'll have to talk more about Andrew on interoperability. That's what I'm going to call it. We'll have to talk about it after we hit stop here. So thanks for coming on the show.
Thank you.
All right, friends. Thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.